let's see. First thing we need is that theorem and postulate sheet we started the other day. It looks like this one here. Hopefully you watched the video for section 2 and already filled in these parts here. But if you didn't, we're just going to talk about these real quick. And then you can kind of have this handy so you can use this on your homework to use these different theorems. So we talked about corresponding angles before. Corresponding angles hold the same spot on your transversal. So like 4 and 8 would be corresponding angles. Now, the theorem that goes with section 2 that you learned is if the lines are parallel, then the corresponding angles that are formed are going to be congruent to each other. So if these lines were parallel, then 4 and 8 would be congruent to each other. That's called the corresponding angles postulate. And then we've got 3 theorems that go with them. The alternate interior angles theorem, once again, alternate interior angles in your picture would be inside the 2 lines being intersected, and on opposite sides of your transversal, like 3 and 6 would be alternate interior angles. Same thing's going to happen here. If the lines are parallel, then your alternate interior angles are going to be congruent to each other. And then I'm going to skip down to the bottom one, alternate exterior. Same thing happens with alternate exterior. If your lines are parallel, then the alternate, this should say alternate exterior. Your alternate exterior angles will be congruent to each other. And then there's one that's a little bit different. It's the consecutive interior angles theorem. Consecutive interior angles, if you go back to your picture up here, consecutive interior angles are inside the lines being intersected, same side of the transversal, so like angles 3 and 5 would be consecutive interior angles. Here's the one that's different. If the lines are parallel, your consecutive interior angles will be supplementary. That means they're going to add up to 180. So the other sets of angles will all be congruent if your lines are parallel. The one that's different is consecutive interior angles. If the lines are parallel, your consecutive interior angles will be supplementary. They're going to add up to 180. So if you haven't updated that yet, go ahead and do that. And then kind of set that aside because we're going to use that as we go through the worksheet 3.2. So just set this one aside for a second so you can go to that and read it. And then go ahead and pull out this worksheet 3.2 that hopefully you've already completed. And what I want to do is just make sure we do one of these together, and then we'll kind of open it up if you guys have questions. So I'm going to come down here to number 8, this last one. On number 8, we need to find y and x, and then we're going to justify it with the theorem or postulate, which is what these were, these theorems and postulates that go with this. So that's why you want to keep that handy as you do this. So on number 8, when I look at my picture, I have a 115-degree angle here. This angle is x, and this angle is y. And then these little arrow marks here mean that the lines are parallel. So if you remember, in the book, there'll usually be a red triangle. But on this worksheet here, we just have little arrows. So those little things mean they're parallel to each other. And so now we can use those theorems. Since the lines are parallel, we can use these theorems that we have right here that we just talked about. So as I look at my picture here, I'm going to start with the x. The x and the 115 are consecutive interior angles. They're both on the same side of the transversal, and they're inside the lines being intersected. And if you go back to our theorem on consecutive interior angles, if the lines are parallel, the consecutive interior angles are supplementary. That means they're going to add up to 180. So as I look at x and the 115, those 2 angles are going to add up to 180. If I take 180 minus 115, I'm going to get 65 for y, or that's for x. So x down here is 65. And then to justify it, I need to give my reason. Well, we just did the consecutive interior angles theorem. We said if the lines are parallel, consecutive interior angles are supplementary. So our answer here would be the consecutive interior angles theorem. And you can do some abbreviating on this if you want to. When you get to the quiz today, you can abbreviate. You don't have to write everything out. So we get x is 65. Now, once x is 65, then I can go ahead and get y very quickly. X and y are vertical angles. And we know with vertical angles are always congruent. So if x is 65, y has to be 65. And then my reason for that would be the vertical angles theorem. Back in chapter 2, we said anytime angles are vertical, they will be congruent to each other. So when you come to the test today, or the quiz today, you're going to have to do both. You're going to have to find the angle measurement, and you're going to have to give a reason. And a lot of times there's more than one reason that will work for these. So if you see something on there, you're just going to use that theorem cautiously. There could be more than one correct answer. All right, that's one we did together. Is there any others on this worksheet here that you want to see up here together? Yes, numbers 3 through 7. You have time? 5? Number 5, this angle is 108. We've got y down here, we've got x down here. So I'm going to start, and then once again, these lines are parallel. They have little arrows on them. I'm going to start with the 108 and the x. Those two are outside the lines being intersected, and they are opposite sides of the transversal. That makes them alternate exterior angles. If you go to your little theorem sheet, alternate exterior angles is at the bottom. And our theorem says if the lines are parallel, your alternate exterior angles are congruent to each other. So the lines are parallel, which makes these alternate exterior angles congruent. X is going to be 108. And since we used alternate exterior angles here, this is the alternate exterior angles theorem. All right, and then once we're there, now you look at the x and the y. These two are a linear pair. They're right next to each other. A linear pair makes a straight line, which adds up to 180. So to find y, I'm going to take 180 minus the 108, which is 72. So y is going to be 72. And then for justifying it, I'm just going to use definition of linear pair. Since those two angles form a linear pair, they would add up to 180. I guess we could say supplement theorem. Supplement theorem might be the better answer here. Let's go with supplement theorem. Since they form a linear pair, they're going to add up to 180, which is what the supplement theorem says. So let's go with supplement theorem for that one. Any others on 3 through 8 that you want to see up here? Okay, you can set that one aside. Hang on to it because we'll put that in the grade book here later on today. All right, the other thing we're going to do is your review for the quiz. So that is in your packet. So go ahead and take that out. Should look like this. And there's two sides to this, but the problems here on the back are actually things that are not on your quiz. So we're just going to worry about the first page and go through this. And this is pretty much what your quiz is going to look like from sections for sections 3.1 and 3.2. So we're just going to run through it. There's 12 problems here on the front. Go through all 12 of them, and then we'll be ready for your quiz. So if you start with number 1, it wants us to name a segment that's parallel to EH. Here is EH down here on the bottom. And we need to name a segment that's parallel to it. Now there's more than one correct answer. So I'm going to put all of the correct answers on here. On the quiz, you'll only have to have one of these correct answers. So there's multiple correct answers, you just need one of them. If you look at EH, we want a segment parallel to it. To be parallel, they need to be on the same plane and not intersect. So if I take the top plane up here, or this front plane, EH is at the bottom of it, AD is at the top. Those two lines would never intersect, so AD would be parallel to EH. If you look at the bottom plane, EH and FG, EH is the front, FG is the back. Those two will never intersect. So FG would be parallel to EH. And then there's one other that sometimes people don't see here, EH and BC. I could draw a diagonal plane kind of coming through this box. that comes from the bottom front and it kind of diagonally comes up here to the back top of the box. That diagonal plane would have EH on the bottom, BC on the top. Those two would never intersect. So that's another option. So again, on the quiz, you just have to have one of those answers. But you got three different correct options there. All right, let's go to number 2. They want to name a segment that's skew to EH. So once again, we're using EH on the bottom here. Skew means they're going to be on different planes and not intersect. So as I look at EH here, one of the lines that would be skewed to it would be CG. EH is going left to right here, CG is going up and down. They're on two different planes. They do not intersect. That makes them skewed to each other. Another one that would work would be BF. BF is going up and down, EH is going left to right. Those two don't intersect. They're on different planes. They are skewed to each other. There's a couple others that would work on the picture here. EH is down here. If I go with AB, AB does not intersect with EH, and they're on different planes. There's one other. I'll let you guys have a chance at it. Can anybody figure out the one other? Simon?
DC.
DC. Yeah. DC is up here, running front to back. EH is going left to right. Those two do not intersect. They're on different planes.
What about BC?
BC would actually be parallel to it. Once again, that diagonal plane could go through the figure and connect EH and BC. So BC would actually be parallel. Any other questions with that? All right, let's try number 3. Number 3, they want a plane parallel to ABC. Now, if you remember in our classroom here, we said parallel planes will never intersect, like the floor and the ceiling would be parallel planes. ABC is the top of the figure, the top of the box. So the one that would be parallel to it would be the bottom of the box, which would be plane EFGH. We just need 3 of those letters to name the plane. So I'm going to call it EFG. And then number 4 would do the same thing. They want a plane parallel to HGC. HGC is the right-hand side of the box. So the plane parallel to it would be the left-hand side of the box, which would be plane ABFE. Once again, you just need 3 of those letters. So I'm going to call it ABF. So there's the first part of your quiz, just picking out parallel, perpendicular, skew parts. Not parallel, or not perpendicular, but parallel and skew parts on our picture. Any questions with 1 through 4? Okay, let's go to 5 through 8. 5 through 8 is one of those where you might want to pull out or have this one handy. Kind of go back and look at your different types of angles. We're going to use the picture to tell what kind of angles we have here, either corresponding, alternate interior, alternate exterior, or consecutive interior. And actually this one they're going to have us pick out a pair of the different types. So yesterday on the homework, they gave you the angles, you told what kind they were. This time they're going to tell you what kind you have, and they want you to pick out a pair of them. So we'll start with the corresponding angles, and this time they want us to name all the pairs of corresponding angles. So if you remember corresponding angles, let's go back to my notes here. Corresponding angles are going to hold the same place on the transversal, something like 2 and 6. They're both to the right of the transversal and above the lines being intersected. If I come over to my picture here, some of them that will hold the same place, 8 and 6, are both to the left of the transversal, or I guess below the transversal and to the left of the lines being intersected. So 8 and 6 would be one pair. 7 and 5 would be another. Those two are both below the transversal and to the right of the lines being intersected. I'm going to run out of room here. I'm going to go up on top. 1 and 3 are going to be corresponding angles. And 2 and 4 are your other segments. So if they hold the same place on your transversal, that makes them corresponding angles. For number 6, they want all the pairs of alternate interior angles. This one, there's just going to be 2 options. Go back to your little sheet here. Alternate interior is where they're on the inside of the two lines being intersected and opposite sides of the transversal, like 4 and 5. So if I come back to this picture here, 2 and 6 are on opposite sides of the transversal, and they're both inside the lines being intersected. That would make them alternate interior angles. So 2 and 6 is one set. What would be the other set?
7 and 3.
7 and 3. Those are your alternate interior. Number 7 is also going to have two answers. They want all pairs of alternate exterior angles. Alternate exterior, very similar to alternate interior, except now we're going to be on the outside of the two lines being intersected. So back to my picture here, 1 and 5 are outside the lines being intersected, and they're on opposite sides of the transversal. That makes 1 and 5 alternate exterior. And then our other option here, 8 and 4, those two are all both outside the lines being intersected and opposite sides of the transversal. 8 and 4 would also be alternate exterior. And then our last one, they want us to name all the pairs of consecutive interior. There's going to be 2 of these. Consecutive interior, once again, if I go back to our picture here, consecutive interior are going to be same side of the transversal, and they're inside the two lines being intersected, like 3 and 5. So if I go back to my picture over here, consecutive interior, angles 2 and 3 are both inside the lines being intersected and on the same side of the transversal. That makes them consecutive interior. And what would be our other option for consecutive interior angles here? 7 and 6, yeah. 7 and 6 are both inside the two lines being intersected, same side of the transversal. Are there any questions with those? Okay, let's go down to 9 through 12. And this is kind of what we did on that worksheet 3.2 that we just went through. This one, they want us to find angles 1 and 2 and state the theorem or postulate that will justify your answer. And when you state the theorem or postulate, a lot of times there's going to be more than one correct answer. Just kind of depends on how you look at the picture. So on number 9, once again, we've got our little triangles here to show that we have parallel lines. And once the lines are parallel, then we can use all of these theorems for our 4 different types of angles. So I'm going to start here on number 9. When I look at number 9, I'm going to start with angle 1. Angle 1 and the 130, those two are alternate interior angles. Since our lines are parallel, we know alternate interior angles are congruent. So angle 1 is going to be 130. And we just said they're alternate interior angles, so my reason would be alternate interior angles theorem. And then angle 2, if I look at angle 2, it's a vertical angle with 130. And we know vertical angles are always congruent. So angle 2 is also going to be 130. That's by the vertical angles there. Let's try number 10. Number 10, we got angles 1 and 2 here. And we have a 45-degree angle inside there. And we can start this one a couple different ways. I'm going to go ahead and start with angle 1. Angle 1 and the 45-degree angle, these are consecutive interior angles. Right here, we got the little triangles to tell us the lines are parallel. You go back to your theorem. Consecutive interior angles, if your lines are parallel, then the consecutive interior angles are supplementary. Supplementary means they add up to 180. So if this angle is 45, these two would have to add up to 180. So to get angle 1, I'm going to take 180 minus 45, which is 135. So angle 1 will be 135. And we said those were consecutive interior angles. So this is the consecutive interior angles theorem. You're going to find most of the time the name of the angle is going to match up to the type of angles you have in your picture. Here we had consecutive interior angles, so we're going to use consecutive interior angles. Now, number 2, I could go about this a couple different ways. The way I'm going to do it is look at angle 2 and the 45-degree angle. The 2 and the 45-degree angle are alternate interior angles. And our theorem, once again, with alternate interior angles, if your lines are parallel, the alternate interior angles are congruent. So since to find angle 2, so we have a 45-degree angle with its alternate interior angle there. Angle 2 is going to be 45. And then again, your reason, those were alternate interior angles. We're going to use the alternate interior angles there. So hopefully the naming of the theorem or postulate will be easy. Hopefully those will just match up with the type of angles you have. All right, let's go down to number 11. Number 11, the first thing I'm going to do here is show our parallel lines. We've got a little triangle here and a triangle here, which means these two that I'm going to kind of color in red, these are your parallel lines. And then we got a transversal going through here, giving us angles 1, 2, and 115-degree angle. And on this one, I'm going to start with angle 2. Doesn't really matter which one you start with. The 115 and angle 2 are consecutive interior angles. Our lines are parallel. So we'll test you guys out. What do you know about consecutive interior angles if the lines are parallel? If your lines are parallel, what do we know about consecutive interior? Those are supplementary. They're going to add up to 180. So to find angle 2, I'll take 180 minus 115, which is 65. And then my reason, we said they're consecutive interior angles. That's the consecutive interior angles theorem. And then once you found angle 2, angle 1 is a vertical angle to it. We always know vertical angles are congruent. So if angle 2 is 65, angle 1 is 65. Since they're vertical angles, we're using the vertical angles theorem. All right, last one, number 12. This one gets a little more complicated because we throw a couple transversals in here. But here's what you need to see on this picture. Your parallel parts, here's the red arrow, here's the other red arrow. That's making these two lines parallel to each other. And then we've got two transversals here. So we need to find angle 1 and angle 2. I'm going to start with angle 1. Angle 1 and the 65-degree angle both lie on this transversal. So if it helps, try to cover up the transversal you're not using. My pen's a little too big here, so let's see if I can find something smaller. I don't know if that helps me or not. So now if I take out that middle transversal, angle 1 and the 55-degree angle, those two are alternate interior angles. There's your parallel line, there's your transversal, makes them alternate interior angles. If your lines are parallel, we know that alternate interior angles are congruent. So angle 1 is going to be, that's a 55 there. And we said they're alternate interior angles, so that's the alternate interior angles there. And then if you look at angle 2, we're going to use the other transversal, this transversal here. And if it helps to cover up this part right here, you might see it a little bit better if we do that. The red lines are your parallel lines. The 35-degree angle and angle 2 would end up being consecutive interior angles. And we just did one of these. Consecutive interior angles will add up to 180 if the lines are parallel. So to find angle 2, we're going to take 180 minus 35, which is 145. So angle 2 is 145. And once again, those are consecutive interior angles. We have consecutive interior angles there. All right, and that's really all there is to your quiz. Quiz over 3.1 to 3.2. All right, any questions with 9 through 12, first of all? All right, any questions with the quiz coming up? Okay, let me shut off the recording here.